Good evening, everyone. I'm delighted to open tonight's talks, and I'd like to thank Passive Buildings Canada, especially Matt Adams and Terrell Wong, for organizing this event. I'm looking forward to hearing from my fellow speakers. I'm grateful to be part of a conversation about architecture's evolving role in sustainability and resilience. I'm Gregory Rubin, founder of Poiesis Architecture here in Toronto, where we design high-performance spaces that balance modernism, sustainability, and site integration. Tonight, I'll share a project that embodies these principles, the West Don Ravine Passive House, a home I designed for my parents. For decades, they lived beside the ravine in North Toronto. And as they approached retirement, they wanted a smaller, more manageable home that maintained their connection to the landscape. But their experience during the 2013 Toronto ice storm, which left them without power for days, also shaped their priorities. They wanted a home that could remain resilient in extreme conditions, something modern. Modernism emphasizes efficiency, adaptability, and technological innovation through open spaces that enhance both aesthetic and performance. Sustainability extends those principles, emphasizing long-term environmental and social impact and resource efficiency. It seeks to harmonize buildings with their natural surroundings while promoting community well-being. Achieving that harmony required a team effort. Designers, engineers, consultants, and builders worked together, designing, testing, building, and commissioning to create a home that met technical, aesthetic, and functional goals. The result is a fully electric, super insulated, airtight home that maintains stable indoor comfort year-round with minimal energy input. But beyond the numbers, this project deepened my thinking about collaboration, sustainability, and how architecture shapes daily life. Because this is a home for my parents, I still visit regularly, not just as their architect, but as their son. And that has given me a rare opportunity to see how the house adapts over time, how it responds to seasonal changes, and how design choices impact real-life livability. One of the important takeaways from this project is that passive house design isn't just about technical benchmarks. It's an approach that integrates site conditions and building systems. Every decision influences the next. Building orientation affects solar gain and daylighting, shaping windows placement, space planning, access and mechanical strategies. Air tightness impacts ventilation, humidity, and indoor air quality, affecting mechanical design and occupant comfort. We focused on three guiding principles. 1, performance. Achieve ultra-low energy use through super insulated, airtight construction for stable comfort and low operating costs. 2, aesthetics. Designing light-filled interiors with clarity in form and materials, maintaining a strong connection to the outdoors. And 3, site integration. Visually and physically connecting the home to the ravine and the sky while managing stormwater and restoring local ecosystems. Windows played a critical role in balancing these priorities. The north-facing facade frames expansive views of the ravine, making nature an integral part of daily life inside the home. But windows are also the weakest point in the thermal envelope, so we needed to find the right balance between glazing and wall performance. With most rooms facing north, which is on the right side of the projector here, passive solar heating was limited. To compensate, we eliminated east and west-facing openings to reduce unwanted heat gain and loss. We used clerestory windows and a light well to bring southern daylight deep into the home. And we designed a sunken garden at the lower level to maximize natural light, ventilation, and views of the landscape. Through this process, we optimized glazing to 11% of the building envelope, including doors and frames. We specified triple pane glass with thermally broken aluminum frames, balancing energy efficiency and openness. This required ongoing quality control. We evaluated multiple window suppliers to balance frame sizes, glass clarity, and thermal performance. During construction, we reviewed samples and worked with installers to refine window-to-wall connections, and blower door testing validated the air tightness strategy after installation. Solar and energy modeling played an essential role throughout this process, guiding key decisions at design stages while aligning performance with aesthetic goals. This integration of passive strategies allowed us to hone in on the shape and quality of rooms, ensuring that each space felt deeply connected to the surrounding landscape. But high-performance design is full of trade-offs. In this project, two major challenges stood out. Embodied carbon versus operational carbon, reducing the environmental impact of materials while achieving passive house performance, and airtightness versus ventilation, maintaining healthy indoor air quality while meeting stringent energy targets. While passive house certification prioritizes operational energy, we also had to address embodied carbon, the emissions tied to material extraction, manufacturing, and construction. Key steps to reduce embodied carbon included sourcing locally for framing, finishing, insulation, steel, and glass to reduce transport emissions, eliminating spray foam in favor of low-carbon alternatives, and repurposing salvaged materials from the original house, working with Habitat for Humanity to donate doors, fixtures, and reusing all the hardscaping. Additionally, site constraints shaped our approach. Toronto Region Conservation Authority, or TRCA, required us to work within the existing footprint and reinforce existing retaining walls. We avoided deeper excavation into native soil and increased soft landscaping in the final site design. Yet demolition still carried a carbon cost, raising important questions. What does responsible demolition look like? How can we design for adaptability and reuse in future projects? Passive design also sets strict targets for airtightness and ventilation, but real-world conditions don't always align with ideal performance metrics. During commissioning, airflow testing in bedrooms proved challenging. Minor CFM variations had big impacts on system balance. We opted for a MERV 13 filtration system for better indoor air quality, even though this went above and beyond the PHIUS baseline for MERV 8 requirements, which also added complexity to the system design. Post-construction, a family gathering exposed another issue. CO2 levels spiked, revealing the system's limitations in handling temporary occupancy surges. And I don't know about the rest of you, but after COVID or during COVID, they started giving out CO2 monitors, and we would just bring them around to all of our gatherings and see what it was like in those spaces. So how did we resolve these issues? So in the design, we made sure that every major living space has an operable window for natural ventilation and cross-ventilation across the house. There's also user adaptation. During large gatherings, my folks will increase the ventilation rate and open a few windows, and this doesn't have any noticeable effect on the temperature. This experience reinforced a key lesson. Performance metrics matter, but so does real-world flexibility. Even on those minus 21-degree days we had last week, the home maintained stable indoor temperature without active heating. The airtight envelope and high-performance insulation keeps energy demand low year-round. This highlighted another crucial takeaway. High performance isn't about individual components, it's about how systems work together. Certification ensures high standards, but it's also a learning tool, helping us refine our approach for future new builds and retrofits. Each project pushes us further, whether in reducing embodied carbon, improving ventilation strategies, or integrating new testing standards. And most importantly, designing for efficiency isn't just about numbers, it's about creating spaces that support the way people live today and into the future. High-performance design often begins with streamlined forms, efficient details, carefully specified materials. This approach minimizes surface area, thermal bridging, and air leakage. But again, real-world conditions demand adaptation. Collaboration across the design and construction teams was essential in navigating challenges while maintaining both performance and constructability. Our goal was to connect the home to the ravine landscape, prioritizing light, spatial flow, and environmental integration. The social spaces were positioned on the lower walkout level, framed by foundation walls that shaped much of the structure. Following passive design principles, we minimized thermal bridging by insulating from the exterior. We used energy modeling to optimize the envelope and align performance with material choices. Fully insulating the exterior reduced the need for interior framing and drywall, cutting down on material use, labor, and waste, achieving more with less. We exposed concrete surfaces, integrating them with terracotta, wood, and limestone to create a tactile, warm interior. But even with careful planning, unexpected conditions arise. During foundation work, the team realized that the insulation thickness specified for the north side footing didn't fit into the formwork. Rather than halting construction, we updated energy models to reassess insulation needs. The results showed targeted reductions in insulation thickness wouldn't compromise performance. We could rebalance insulation elsewhere, optimizing material use. And constructability actually improved, saving both materials and labor. This collaborative, data-driven approach ensured that we preserved thermal integrity while streamlining installation. This process reinforced 3 key takeaways. Adaptability. Clean design concepts provide direction, but must evolve to accommodate real-world conditions. Energy modeling as a tool. Simulations allow for informed decision-making and flexibility during construction. And collaboration drives performance. High-performance projects thrive when consultants, contractors, and trades work as a unified team. Bringing technical knowledge and craft together was essential in making this passive house a reality. But one of the more unexpected outcomes of this project was how it extended beyond the house itself, influencing conversations, community engagement, and ecological stewardship. Since the site is on a TRCA-regulated ravine land, we had specific restoration requirements following construction. However, we saw an opportunity to go beyond compliance, to develop a holistic ecological plan that would restore and strengthen the connection between the home and the ravine. We worked with urban forestry and ecological restoration specialists to create a ravine stewardship and management plan. This approach incorporated removing invasive species like Norway maple and buckthorn, which were outcompeting native plants, stabilizing foot trails and managing stormwater naturally to prevent erosion, and restoring native plant diversity, reinforcing the ecological connection between the site and the ravine corridor. This plan didn't just serve the property, it became a catalyst for broader engagement. As we implemented the plan, we found ourselves in unexpected conversations with neighbors and passerby. A next-door neighbor allowed us to remove invasive buckthorn on their property, extending the restoration efforts. Regular walkers on the street would stop to chat, curious about the project and its connection to sustainability. A retired master gardener who lived nearby was excited to see the use of native plants and began sharing insights and resources. And one old lady who told my folks that seeing the garden each day had become a highlight of her walks. These organic interactions reinforce something important. Sustainable design isn't just about technical performance, it shapes daily life and creates shared connections. A further unexpected but exciting collaboration emerged with the Toronto French School, whose K-12 campus backs onto the same ravine. They were launching their own ecological restoration initiative and reached out to learn about our work. This led to sharing our ravine stewardship plan, helping the school refine their own ecological goals, connecting with other stakeholders, including Crescent School, Sunnybrook Hospital, and Glendon College to discuss broader ravine conservation efforts, and using the house as a case study, integrating it into forest classroom programming for students to explore sustainable architecture and ecological restoration. These conversations and partnerships reinforced a key takeaway. Sustainable design creates opportunities for engagement, regeneration, and shared responsibility. What started as a house became a learning tool, a community conversation starter, and a model for ecological stewardship. Looking ahead, we're applying these lessons not just to new buildings, but to existing ones. It's about making sustainability scalable, adaptable, and accessible. This is where deep energy retrofits play a crucial role. Retrofitting existing buildings, upgrading their envelope, mechanical systems, and fuel sources can bring them up to the performance level of new construction. Not every project will be a new build. Not every project will pursue passive house certification. What matters is applying the principles of high-performance design in ways that work with existing spaces, reducing energy use, improving comfort, and cutting carbon emissions across more of the built environment. To do this, we're focusing on 3 key areas: material innovation, prioritizing embodied carbon reductions, adaptive reuse, and life cycle impact over a project's full lifespan; testing and commissioning, embedding performance validation into every project to ensure real-world results align with design intent; collaboration and leadership, expanding cross-disciplinary knowledge sharing to make high-performance strategies more actionable and widespread. Each of these focus areas is already shaping our work, with one of our latest projects, a deep energy retrofit of a multi-unit building in Toronto, starting construction in March. We're all shaping the built environment, whether as architects, builders, engineers, or advocates. So let's advocate for better energy performance in every project. Let's prioritize testing and commissioning as a norm, not an exception. And let's push for deeper conversations on embodied carbon, resiliency, and adaptability. This project reinforced an essential lesson. Sustainability isn't a static goal. It's a continual process of learning, adapting, and refining. These projects deepen our understanding of how to balance performance with real-world constraints. Certification isn't the end goal. It's a tool for ensuring accountability and driving innovation. And the future of high-performance design isn't just about energy efficiency. It's about resilience, adaptability, and the spaces we create for people. As we move forward, the question is how to shape places that improve the world around them. For me, this is where I see the future of high-performance architecture: enduring, adaptive, inspirational. Thank you.